Welcome back to the 7th Python tutorial in this series. Hopefully everyone watching this has attended or watched the first 6 sessions. So altogether, we have computed wind chill index, heat index, and dew point. We've also refactored our code into reading, printing, and computation modules. So if you had any technical difficulties up to this point, hopefully we were able to set up a meeting time and work through them together. My name is Julia. Hopefully we know each other by now, and I thank you so much for going through this series with me. This will be the last session of the Pure Python spin-up. Before we begin, I need to review our code of conduct. By joining the Zoom call and participating in this tutorial seminar series, you've agreed to adopt these values and engage in respectful communication only. Inappropriate remarks in the chat will have you removed from the call. All the commands are up on the website, the NCAR Python tutorial site, and you should also look at the Project Pythia website and Stack Overflow. Okay, and again, just to review, we've done wind chill index, heat index, and dew point. So give me a second to transition over to a terminal and we can begin our work there. Okay, hopefully everyone can see that. And that you have your tutorial open as well. Okay, so today's lesson is going to tie everything together, hopefully, and it's in that it shows you how to prepare your package for publication. This step shows you that your package isn't that much different from a package such as math or any other toolkit you might want to use in your analysis. It also shows you how to make your work available to other scientists and how to make best use of other people's work. So let's take a look at the current state of our project again. So I'm going to move into my project folder. Okay, where am I? I'm already in documents. Okay, so just move into the correct folder and do a conda activate. Okay. So I actually, since our last session, completely uninstalled and reinstalled my conda. So if I have any issues related to that, we'll work through them together. But I don't predict that we'll have any. And let's look at what we have. Okay, we have our 3 scripts. We have a just math test script, and we have a MySci folder and a data folder. So if we look inside any one of these main scripts with the dew point temp comp.py, you'll see that we have our 3 import statements. We have 2 dictionaries that define the data we want out of our original text file. And then we're able to read the data in just a 1-line call, do the computation we want in just a 1-line call, and also print out the comparison in a single line. So this is super clean, easy to see what's happening. And if we want to look into any one of these, it's all compartmentalized. The code is being reused effectively. And if we want to change one aspect of the code, it's a lot easier to see where that's happening. So hopefully everything is more robust and more flexible, and you don't have to track down changes in every single one of your files when you just make a change to how you're reading the data. say you just used a different data set that you still wanted to compute the same things. Instead of copying your entire file, you would just write an appropriate read data module for that new data set and then apply that. And it's much more quick to see where those changes are going to be. Okay, so already in our current state, since we've pushed this up to GitHub, we should be able to copy anything that's on GitHub and publicly in a public repository with the following commands: git clone, and then the name of your repository. So github.com, your username, and then whatever your repository is called, .git. Okay. I'm not going to execute this line right now, actually. So this command would create a new directory in your working space with the same name as your repository, but still, in order for it to function, you have to copy it into your project space. And you would do this with pip install and then the name of the directory that you just created. So that would look like a pip install Python tutorial 22 after you've done the git clone. Again, I am not going to execute this line right now. So pip is this tool for package installation in Python. It stands for package installer for Python, PyPi pip. This is similar to Conda when we do Conda installs, though Conda is good for installing all kinds of packages, not just for Python. You might use it for a different coding language as well, but pip is specifically for Python, and so it has capabilities that are great for maybe installing things that aren't officially in the Conda ecosystem, such as a random GitHub repository or a more experimental package. And also, when you're trying to install things, if a Conda install of that name does not work, the first thing I would try is pip install of that same thing. But it's best to try and be consistent as much as possible. Okay, yes. So your pip install right now, we have to properly package our content actually by adding just like one little file, and we're about to do that. So I'm not surprised that it's not working at this very moment. We are going to, because you can still access the code with the git clone, but to import it just like anything else, we have to do some steps to tell pip how to install your package, which we're going to basically say do it the usual way, but we still have to tell it to do that. Okay. So, but also when we get to there, you can do this, these same two commands in one line with pip install git plus HTTPS, and then your URL. Let's call it repo for this, like that. Okay, again, I am not running it quite yet. I'm just showing you what the commands look like. Okay, so even better than doing this one line is something called PyPi, which is the Python package index. And we will publish our package there, which allows other users to install the package with the one line code. So this is what we're after. This is what we're hoping to achieve by the end of this lesson, is going to pip install and then your repo name. your repository name like that. That's going to be the goal. We're going to make that possible. But first, let's package our code in the official happy way. Okay, so the first thing we're going to do is create a setup.py file. Okay, so make sure we're in the correct spot. We actually want to be inside of the MySci folder, I believe. No, okay, so it needs to be one level above the MySci folder. So if your directory looks like this, perfect. Okay. We don't have to change anything. Do a touch setup.py to create your new folder. Okay, and then we are going to edit this file with nano setup.py. Or a Vim, again, is a perfectly good alternative. And this is where we'll enter the required information to tell pip what to do with our package. So we actually are going to do a import of a package that is new to us that's used for this, which is called setup tools. As you can imagine, this is a tool we're using to set up our package. So from setup tools, import setup. And then you just call the function setup. And here are the arguments it takes. So it takes the name of your package. Okay, have a comma in between each argument. And because there's quite a few of them, I'm going to do them each on a separate line. This is totally optional. This is more of a styling thing. If you prefer to have your function call on one line, if that makes more sense to you, it doesn't make much of a difference. This is just easier to find which argument you're trying to change. So you've given your package a name. Now you also need to version it. So this is our first time doing this. So it's going to be version 1. If you wanted to go back in and add more functionality or different types of data reading, you could republish this with a new version. Okay, don't forget your commas. And then a description. I'm just going to call it a sample package description. So again, these are all strings. So make sure they're in single or double quotes. You are the author, so put your own name here. Add your email. Okay. And then you're going to tell it which packages you're installing, like actually point to them. So you're going to do that inside of a list where each element is a string. And for us, it's just the one, which is our MySci package. And finally, this is an important one, is install requires is the last key. And we're going to just set this equal to an empty list because our installation doesn't require anything special, but we still have to specify that it doesn't require anything special. And then close out your argument. Okay. Well, actually, sorry, I misspoke. This is not technically necessary, but it is in almost every package that you would create. You would find that it's necessary. So I still want to demonstrate kind of the typical steps. Okay, so let's save this and do a git push. And try out pip installing it, and then maybe we'll go visit the PyPi site and explore that a little bit. Okay. Let me do a click clear. Okay, so you should now see your setup.py. Let's do a git add. Git commit. Okay, and then git push origin main. And this sends everything back up to our GitHub repository that we created a few lessons ago. If you had problems accessing GitHub, if you chose to not engage with that part of the tutorial or we didn't fix it, basically the rest of this isn't going to work either. So this is dependent on the step from the previous lessons. So maybe stop here and go back and revisit those. Another reason this command might not work for you is if your Git branch is still called master instead of main, which is a holdover from an older version of the language. And you can quickly fix that with a git branch -m master main. So the old name and the name you want to change it to. Okay, I am again not going to execute this line. If any of you are wondering how to not execute a line, you can do that with Control-C, and then it'll just move you to the next terminal line without you having to delete all the way back. Okay, so now you should be able to install your package locally with a pip install dot, with the dot referring to your current location is what we're installing into our environment. Okay. Fingers crossed. Okay, successfully installed. I'll give a minute and make sure everybody else was able to do it this time. Okay. We can also check that this is installed. Let me do a clear with a conda list. And this lists all of the packages in our current conda environment. And you'll see we've got version 1 of MySci right here. Okay, so let's actually uninstall it so we can practice installing it in a different way as well. So pip uninstall MySci. Would we like to remove it? Yes. Uninstalled, okay. And we can check that that worked again with a conda list. Okay, so let's try the GitHub methods. So that looks like pip install git plus https // github.com/your username and the name of your project. Okay, so that still worked. It took a little bit more time, I think, to access and find than when we said to just install where we currently were. And again, with a conda list, you can see it there. So this is great. It means that we are ready for publication. And we're going to go visit PyPi, the Python package index. In this space, in the package index, every namespace has to be unique for packages. So we're not going to actually literally publish MySci. We would probably need a more unique package name than a very typical tutorial package name. I'm sure that my site has already been taken and we don't want to, you know, unnecessarily clutter the space with something that we're not going to actually access. So there is a PyPi like practice site that you could also visit, but let me put this in the chat, the link to PyPi. Okay, so we are going to visit here, and give me a second to log in with my password before I share the screen. Okay. Sorry, I seem to have my password wrong, so this is just going to take a second. Okay. Okay, back to here and okay. So we are now logged in on PyPi. If you registered yourself, you should see a page similar to this, and all of the projects that you're involved with, all the packages that you have authorship that are downloadable for other people. If you just registered, you probably, this list will probably be not existent. So we are going to create a new project, and we have one more step actually in the terminal. So let me go back and forth here. Okay. We need to install an external package called Twine, which is a tool specifically for publishing packages up to PyPi. So this looks like a pip install Twine. Okay, great. And now we need to use our setup.py file, that script that we just wrote, the single function call, and use it to build the distribution of our package. So that is Python setup.py to call that script, but we actually are going to also add sdist and bdist wheel. So these are going to kind of give Python more direction about what we want to have happen. Okay. So now if you do an ls, you will see that we have this new egg info folder here that contains some of the information necessary for our package. It's our distribution folder. And so now, if you do a twine upload, dist for our distribution folder actually right here. So we have these two that are new. And then this like that. Okay, you'll be prompted for your PyPi username and password, which you just set up. Okay. And so we can't upload it because the file name has already been used, like we predicted. But if we were working on something brand new, it would be uploaded. You would come visit it over here. You get to wash your hands of it before you get into the headache of maintenance. And voila, you have already, you've made a Python package from scratch. We started with just the basics of Python, reading in a text file, and then learned about a lot of data types along the way, different data structures, loops, and then we built modules and packages. So hopefully you feel much more confident with the components and moving pieces of a Python ecosystem at this point. It's important to note that we did not cover some key Python object-oriented concepts such as classes, and we didn't really go into if statements, sets, things like that, that you might be familiar with from other languages. The syntax for those things should feel familiar. It follows the same basic rules. Classes, we could devote an entire semester to classes and using them efficiently. So for this purpose, I just hope that the tutorial has provided you with the building blocks for understanding these concepts as you use them. So in the sessions to come, we will be covering more. And this is the conclusion of the Python tutorial spin up. So we're going to take a short break. We're preparing for a fall event, a NCAR, ESDS, and GeoCat tutorial and hackathon. And we're going to focus on building content and getting prepared for all the logistics of this hopefully hybrid session. So look for some emails about that. And with that, thank you all for coming, and we'll take some questions now.